Play, it's going to all go black. And then go to this thing. Okay. We have about 5 more formulas we need to deal with. Okay, we're going to do 2 today. I tried to pick the 2 easier ones, but it means we're not going to go in order on the notes. So I need you guys to skip down to the formulas that are just before example 16. So it should say that right there. Okay. All right. Did you have a pass? What?
I haven't said the first, so just let me in.
Okay. All right. Everybody has essential question or right here on where it says product to sum formulas. Okay. So there's a whole bunch of these formulas, right? And again, our purpose is I don't want something to come up in the calculus problem somewhere and you not understand that, oh, maybe recognize it is one of the identities that where one of these goofy formulas can be applied. It happens very rarely, but it does happen once in a while. So I want you to have at least the exposure to it, which we didn't get last year. Okay. So yesterday our formulas looked like sine of u plus v. You see how this one is multiplied, sine times sine. There's 2 sines, whereas yesterday we were adding 2 things, adding 2 angles together embedded in the sine. You see the difference? Okay. And we're going to look at that again when we do the other formula we do today. So what this is saying is it's giving you a conversion. All formulas are converting from one thing to another. You're in calculus, I should be able to throw any formula at you, tell you what some of the variables mean, and you be able to convert from one half of the formula to the other, right? You should be able to do that at this point and have that skill. So this is saying we have a product of something and we're turning it into either a sum or a difference. A difference is just a sum added a -1, right? So what you're basically going to do is you got to figure out which one of these 4 you have, and then you're going to use the associated formula on the right side. Okay? So and then the U and the V stand for whatever the angles are. They might be in radians or degrees today. There's a little bit of both. Okay. And then we have to simplify. These ones are pretty easy. Okay. So we're going to start with the product to sum formula. It actually tells us product to sum in the instructions. Okay. So you have cosine times sine. So if I come back here and I look for cosine times sine, I want to use that bottom formula, right? So what I do is I write out the skeleton of the formula and then I drop my angles in there. Okay. So cosine times sine, what does the formula start with? 1/2. And you'll notice all of them in this particular set all start with 1/2, right? But all the formulas are just a little bit different. All right. What's the next part of the formula? Sine. And then what operation goes in there? Just give me the operation. I don't want the angles yet. Plus. Okay. And then what operation goes between the 2 functions? Minus. And what's my next function? Sine. And then my operation in my last set of parentheses? Minus. That's what I call the skeleton of the problem, right? We did a lot of skeletons last year when we did the functions transforming, right? I write the skeleton of the problem and then I drop we're dropping our numbers in. We're dropping our angles in. So my angle this time says 5x and 4x. Those look kind of goofy, but we're going to go with it. 5x and 4x. It isn't like a, pi over 6 or something like that. All right, and now I'm just going to simplify what I've got. So I see 1/2 sine, what's 5x plus 4x? 9x minus sine of what? 1x or just x. Done. That's all you have to do with it. Not nearly as complicated as yesterday, right? Yeah. No, it doesn't. You could use the brackets and probably in theory I should have probably, but it doesn't matter if you use double parentheses or brackets. So whichever one makes more sense to you is fine. That's a really good question. Okay. You always want to make sure you have an open and a closed and that they match up, right? Back 15, 20 years ago, we were really careful and conscientious about that because the way our calculators work, but now our calculators almost pop them up for us. Okay. And Desmos definitely pops it up for us. Okay. All right, let's look at 17. All right, so it says cosine times cosine. So you're going to go back and look at your formulas, and you're going to find the one that says cosine times cosine. Everybody got it? Okay, so how does our formula start? 1/2, good. All right, and then what is my first function? Cosine, and I'm going to draw parentheses. What operational symbol goes in there? Minus, and then the operation between the two functions? Plus, and then the next function is? Cosine, good, and then the operation in the last parentheses? Plus. And now I can drop the two angle measures in there, right? 2 theta, 4 theta. 2 theta, 4 theta. If I wait to drop the angle measures in until after I have all my signs, then I'm not bogged down in what has to go in order, right? I know my angle measures just drop in at the end. That's the way my brain works. Your brain might work differently, but that's the way I work. Okay? All right, so we're going to go 1/2. Cosine, what's 2 theta minus 4 theta? Ooh, negative 2 theta. That's a problem. All right, cosine of what? 6 theta. On the parentheses embedded in the trig, I don't necessarily need them here, but I have to have them when I have a negative there. Okay? So that's the proper notation is to put the parentheses around anything that's inside of a trig. Okay? I'll tend to drop it a lot of times, and you'll see that happen too on other places. All right, look at the green sign. This is an identity from last year. And I know I only have the green sign up on this side of the room. I'm sorry. Okay? On the green sign, do you see it says cosine negative u? It's the second line. Equals cosine u. So what's going to happen to this negative? It goes to a positive, right? That's the even and odd one. So it means that cosine was probably an even function. That's why it went positive. All right, so all we're doing is applying that formula, right? So I'm going to just say 1/2 cosine of 2 theta plus cosine of 6 theta. Notice I dropped my parentheses on that one. Okay? Although I almost should have put parentheses looking at that S and that 2. Might be unclear what that is. Okay? All right, we go to 17? All right, 18's ugly. And I will tell you, and you'll find this out within probably the next month. The worst part about calculus is easy. Okay? It's the algebra embedded in the calculus that's hard. This is a good example of an algebra embedded in a trig that's going to make it look really icky. Okay? Once we get it in there, it's not awful. Okay? But there's going to be pieces of algebra that make things look very complex. Okay? That's why you take 2 years of algebra, right? To be able to make sure you get to the complexities of algebra that you need. All right, you got a sine times a cosine. What are we going to write out first? 1/2. What's the next piece of the formula? Sine. And then notice how big I'm making this set of parentheses. What operational symbol goes in? Plus. Good. And then operation between the two pieces of functions? Plus. And then what's my next function? Sine again. All right, and then it's a big parentheses. What operation's going to go in there? It's a minus, right? Okay, now, our U and our V are really weird this time. Okay? This is the U. Do it in different colors. That's the V. Does that make sense? So whatever weird thing they put in there, you got to go with it. So for the U, I'm putting in X plus Y in both spots. And then for the V, let me get the right color, I'm putting in X minus Y in both spots. Does that make sense? I literally plopped in exactly what they wrote, what the problem wrote in the U and in the V. Now I'm going to simplify the algebra that's in those parentheses inside the pieces of trig. So I've got 1/2, I've got sine. All right, what happens with X? I don't really need the parentheses, right, that are inside there. So what happens with X plus X? 2X. And then Y minus Y? 0, they cancel, right? We would say they cancel. So just sine 2X. Plus, it's sine, again. What should I do with that negative first? Distribute. And we are lazy about our distribution. We don't write a whole nother line for that. We just scribble over the top, right? Probably not a good habit, but who wants to write all that out again, right? We try to not make them a million lines long. All right, what happens with x minus x? Cancel. And then y plus y? 2y. Done. Okay, we good? All right, so those were product to sum formulas. Okay, now we're going to go the other way. We're going to go sum to product. Now, this can be confused with what we did yesterday. So I want to let's look at the difference again. Yesterday we saw this. Do you see how the u plus the v are inside the sign parentheses? This one is a sign plus another sign. Do you see the difference? Okay, so if we see this situation, we use the sum and difference formulas. If we see the sine plus the sine or the cosine plus the cosine, we use sum to product formulas. Okay, and again, these ones are, if I had to memorize them, these ones would probably be slightly easier. They've all got 2's in front. It's all u plus v in the first one and u minus v in the second one, and they're all divided by 2. And then you got to kind of figure out which one is what the two pieces of the two trig functions are. Okay? All right, so I'm going to let you help me find the formula. So this time, and I want you to examine the formulas. I'm not going to go back and circle one for you. We have a sine plus a sine. So how is the formula going to start? 2. Okay, what piece of trig goes first? Sine. Inside there, I know it's divided by 2. What's the first operational symbol? Plus. And then what's my next piece of trig? Cosine. And then my operational symbol in there is minus. And now I'm ready to plot my angle measures in there. So 3 theta, theta. 3 theta, theta. All right, 2 sine. We're going to simplify in there. So what's 3 theta plus theta? 4 theta over 2. Cosine. 3 theta minus theta is 2 theta over 2. All right, so what's 4 theta divided by 2? And we don't necessarily have to simplify, but our eyeball really doesn't like that, right? You're probably in your gut, you want to simplify when you see something like that. Cosine of what on this next one? Theta. Okay. So either one of these is correct answers. Likely if it was multiple choice, we would see the second one. Okay. All right. 20 gets uglier. Because again, look at your u value, right? We've got this mess in there for u. All right, so it's going to be a little bit messier. So this one says cosine plus cosine. So go look at your formula chart. Okay, so in your formula chart, what is the formula going to start with? 2. Okay, and what's my first function? Cosine something, and then is it plus or minus? Plus. Okay, and then is it going to be sine or cosine? Cosine. And notice this one's multiplying, right? Because we're supposed to be going from a sum to a product. All right, and then what's my operational symbol? Minus. Good. Notice how funky I spaced it, right? Because of what was coming in. This whole piece is the u, so I have to say alpha plus 2 pi. Alpha plus 2 pi. And then my second piece is just the alpha. My v is an alpha, so I add an alpha onto the end. All right, in my next line, I'm going to split up a fraction and do some algebra to make it easier to simplify. Okay, so 2 cosine, what's alpha plus alpha? 2 alpha, and then plus 2 pi, right? So I have options here. Either I can separate that into 2 separate fractions, both with the same denominator, or I could factor out a 2. I'm going to go with this because then I don't have to write another line of work to factor out the 2. Okay, but it's up to you, whichever one makes more sense to you. All right, and then here, what happens with the alpha and the alpha? They cancel, so we've got cosine of 2 pi over 2. What happens with the 2's? They all cancel, right? So we've got cosine of alpha plus pi times the cosine of pi. Isn't the cosine of pi a number? Isn't it a number from our unit circle? It's -1. Look at how much of the unit circle I had to draw. Did I have to draw much? No. And that, my brain, I know I probably don't need to draw the XY axis, but every time I think unit circle, I start by drawing the XY axis, and I start by drawing the coordinate that I need, okay? Or the unit coordinate, the axis coordinate that I need to get to whatever quadrant I'm in, okay? All right, so I know that I'm replacing that with -1, so my final answer would be -2 cosine alpha plus pi. All right, we good with 20? We're only going to do one more. Okay. This one happens to have a degrees in it, but that's okay. All right. So we've got cosine plus cosine. It's going to be a little bit different. They want an exact value. The instructions are slightly different. So we are going to have to use our unit circle a bit. What does this formula start with? 2. And then what's my first function? Cosine. And am I adding or subtracting first? Adding. And then what's my next function? Cosine again. Are we adding or subtracting? Subtracting. And then we're going to drop our angle measures in 195 and 105. 195 and 105. So you've got 2 cosine. What's 195 plus 105? And I know I took all you don't have any calculators and no phones. What is it? 300. That wasn't so bad. All right, 195 and 105. 90. All right, we're going to divide that out. So cosine, what's 300 divided by 2? I probably don't need parentheses. And then 90 divided by 2? Good. All right, I know I've got the 2. Now, I do know that cosine of 150 and cosine of 45 can be evaluated, can't they? So out -1, up 0. Isn't 150 this one right here? So that's 1/2. So that means that one has to be square root of 3/2. That one's negative. So what is the cosine of 150? Did I have to write out my entire unit circle to get that? No. I wrote out as much as I needed, right? Because the 45 is there. I almost don't. 45s are easy, aren't they? Aren't they always this? Yeah. And then, so what is the actual cosine of 45? Square root of 2/2. Okay. Oops. That was too far. What happens with these 2's? Cancel. So across the top, it looks like I've got negative square root of 6, and on the bottom, 2 for my final answer. So it's all about applying the formula. Okay. All right. Let's see where we're at. Oh, we've got lots of time left. Okay. Well, here's what I'm going to give you a chance to do. Okay. You're going to take 5 minutes and study your unit circle. Okay. And then we will get going on the unit circle quiz. Okay. While you do that, I'm going to get homework posted. Okay. Yes. Yes. Take the pass.